Good afternoon, everyone. How are you doing? How was the keynote? Anybody attend keynote? Okay, excellent. So welcome to the session. In today's data-driven world, the ability to scale analytics for your organization isn't an advantage. It's a necessity, right? So we are here to explore how AWS can help revolutionize self-service analytics and also empower every team to be data experts in your organization. My name is Srikanth Sopirala. I am a Principal Analytics and AI Specialist Solutions Architect, and I am joined by my colleagues Utkarsh Mittal, who is a Product Manager for DataZone, and then Raghav Rao Sodabatina, who is also a Principal Solutions Architect. In this session, we will cover how you can leverage AWS analytics services to democratize data insights and also drive innovation across your organization. We will start with a couple of polls just to kind of get a pulse of where we are in terms of your journey with self-service analytics, and then I'll jump into the agenda. So raise of hands. How would you rate your organization's current self-service analytics capabilities? A, non-existence. How many A's here? Okay, there is one. Awesome. Basic, which is limited and only few users. Any raise of hands? Okay, there is. What about intermediate? Like you have some tools, but you're growing user base? Okay, there you go. And then advanced. You are completely good with it. Maybe you're in the wrong session then. But wide range of tools. How many raise of hands here? Okay, you got it. Okay, excellent. No, I think that's what I was expecting. Mostly, I think what we've seen is B and C is where people are in their journey in terms of self-service. Let's take another poll. What is the biggest challenge that you face implementing or scaling self-service analytics? Data governance and security concerns. Raise of hands. How many? Okay, that's great. Lack of user skills and training in terms of data tools. I see a few hands. Yep, more there. Limited tools or infrastructure. Okay, and that's where cloud can help. And then resistance to change of your end users or your business users, basically from the traditional BI processes. How many raise of hands here? Okay, yeah, I think that's expected. So that's great data points, right? Sets up pretty well for our presentation. So let's jump in. In terms of the agenda, what we're going to do today is we're going to level set on what self-service analytics is, because it's a pretty broad topic, so I want to kind of hone in on what that is. And also building blocks of self-service analytics in terms of the foundation, right? We will talk about that. And also then we will talk through self-service analytics on AWS. How can AWS help you with self-service analytics? And then some resources we will give you so that you can use them. Okay, so what is self-service analytics? Self-service analytics puts data, tools into everyone's hands, right? Not just the data experts in organizations, right? This helps people make decisions and drive innovation quickly for the whole organization, not just the IT teams. I mean, that's how we are defining self-service analytics. So if you look at it, the global self-service analytics market is expected to reach about, $13.81 billion by 2029. That is pretty staggering in terms of what that market looks like. The other thing which also we see, which is another staggering statistic, is 70% of business users they want their self-service analytics tools to make data-driven decisions without their organization's IT or data teams. That is staggering, right? Because 70% of the organizations want that ability. So, but the problem is, in today's world, self-service analytics kind of promises to empower everything, right? Which we talked about in an organization. But the path to the self-service analytics, the path to the democracy is basically fraught with a lot of challenges, significant hurdles. Right? In terms of businesses, what they do is they strive to get to the full potential. They face critical challenges. So one of the critical challenges that we talk about is extensive, ETL pipelines. We spend a lot of time building ETL pipelines and making it more and more complex data preparation. That is completely a big hurdle for self-service analytics. And also, we have scattered data all over the place. What we have seen is, the ability to discover your data sets, which is basically another utilization or finding the data sets is it's a big bottleneck. And then as the organization's data is growing, in terms of the footprint, what we are seeing is the scalability and performance of those tools that they have to enable self-service analytics is limited for most organizations. And then the fourth one is technical complexity, right? If you think about it, traditional analytical tools are generally maintained by IT departments, right? So there is expertise, and when you have these tools which require special skills, it limits the adoption across the organization, right? And then last but not the least is enabling ML for all of the organization, meaning limited advanced analytics capabilities in the hands of your end users. That's another big technical challenge. Now, these are the building blocks of self-service analytics, right? Where real-time insights. The idea is to have the users get self-service analytics where they can get real-time insights from the data from their OLTP systems and things like that. That's one of the building blocks. The other building block is AI-assisted insights. Because most of our customers want to leverage artificial intelligence, generative AI, and the deeper understanding of their data, right? And then the third building block is unified data. We have been building silos for a long time, so the ability to have that data in one place, a single copy of data, is an important building block for self-service analytics. And then once you have that data, discovering the data becomes a big problem, right? So discoverability and finding the right data set is another building block. And then the ML for all, where you want to put the ML in terms of your end users, so they don't have to be data science, because data science skills are limited. So that's ML for all. That's another building block for self-service analytics. And then the last one is, once you curate the data, once you have all of this data, simplifying the development and providing them those experiences to build the analytics is an important building block. So what I'll do in the next few minutes is I am going to go through, dive a little bit deeper into each of those building blocks and give you some idea of how AWS can help. So the first building block is Zero-ETL. So Zero-ETL is basically, is a enabler of self-service analytics. The idea here is to simplify data integration across your analytics, across your transactional systems, right? Accelerate and also optimize your transactions. And then drive better outcomes in terms of what your end users want. So let's talk about Zero-ETL here. So at AWS, what we are trying to do is we are working to make Zero-ETL between different systems, easier, so that you can get your data, move your data from point A to point B without doing a lot of ETL complex pipelines. Zero-ETL integrations bring transactional and also the analytical data into one place, so that way you can run your analytics. Let's take a simple use case here, right? So you have a business analyst, let's say your organization, where they need to kind of get analyzed data from a database, and they don't have right technical skills. And that is where Zero-ETL can help. In this case, you have data sitting in Amazon Aurora Postgres, and then you can enable, by a simple click, you can target, you connect to the source, and then you can connect to the target, and then you can start the Zero-ETL journey pretty quickly. So the idea here is to give your end users the ability to get data quickly in real time to the target. That way they can quickly run analytics. So that's where Redshift can help in terms of that Zero-ETL integrations. And then also the other Zero-ETL integration is not only self-service analytics. With the Zero-ETL, what you can also do is curate the data in Amazon Redshift, and then you could use data sharing to enable for line of businesses in terms of self-service analytics. So you can have data sharing as a thing where you can enable self-service analytics. And then this is a great tool where, auto copy from Amazon S3 to Amazon Redshift is a great feature. We're always trying to get data into Redshift faster and faster, right? So the auto copy automates the data. As you drop the files into S3, you can now copy the data from S3 automatically with schedules into Amazon Redshift. And this becomes a tool for your business analysts, tool for non-technical users to get data into Amazon Redshift. So that's a zero copy for self-service analytics. Now, I think you have native sources, you have native databases in AWS, but there are sources, third-party sources like Salesforce, which have a lot of data. It can be SAP. So what we have done, this is a new announcement, where you can do Zero-ETL from Salesforce and get the data from Salesforce into Amazon Redshift or into your data lake, having that data set, right? We had before where you can have connectors to these third-party products, but now we have enabled the Zero-ETL, so you can get incremental CDC data automatically into your lakehouses and into your Redshift data warehouses. And that enables the Zero-ETL, that enables the self-service analytics capabilities. Now, to summarize, Zero-ETL is a powerful tool to kind of get to self-service analytics for your end users, right? Because it's easy and reliable, you can quickly enable that. It is a low latency data integration. You don't have to really work on building all of this, not much time spent. Also, unified insights, getting all of that data into one single place with Zero-ETL mechanism. And then the third one is the optimizing cost, meaning you don't have to constantly create and feed these complex ETL pipelines, and that's where I think you can save resources and also cost. Now that we've talked about Zero-ETL, let's talk about the second building block here. The second building block is unified data without silos, right? That's where lakehouse comes into the picture, right? Unifying platforms where you can get all your data, right? Flexible schema on read options, and also enable self-service. That way you can get one copy rather than having all of these silos, which also the other key thing is scalable, right? You need a mechanism to scale your analytics opportunities, and that's where lakehouse comes into picture. Now, let's talk about what that is. So what we've been doing for many, many years, I think we are all guilty here, we have been building data warehouses, we have been building data lakes, we have been creating these silos, right, for your line of businesses, we've been doing that. And also, I think what customers want and what they've been telling us is they want to enable self-service by providing, transactional data and the analytical data in one place where they're performant like Amazon Redshift, and also they're ACID compliance in terms of that. And that is where we are kind of reimagining the lakehouse approach, right? The idea here is a single copy of data, so you don't have to constantly keep these silos, and also whether it's semi-structured, structured, or unstructured data in one place. And that is what this morning Matt announced, the lakehouse, right? Amazon lakehouse, SageMaker lakehouse is basically that construct. So what is lakehouse? Lakehouse, first of all, enables you to kind of build that self-service nature, because you can now use your Zero-ETL and then get that data into your lakehouse, whether it's unstructured, whether it's semi-structured or not. Right? There are three key features here, right? It's a unified data where you can have all your data in one place. It's open, compatible with Apache Iceberg compatibility, and also it's secure because we have the data, AI, and governance in terms of that. So that's lakehouse. And then lakehouse also provides access to your unified studio, which we will talk about in a second. It simplifies development, and also third-party products where they can access the data from your lakehouse, and then that through self-service manner. The other component, let's tie in how we can get the Zero-ETL and federation to the lakehouse, right? We have talked about Zero-ETL. Now what you can do is you can kind of take the Zero-ETL approach and then consume that data, get the data into your lakehouse, also federate into your lakehouse where your end users, your business analysts can now do self-service analytics on that lakehouse. So this is another great feature. So in summary, I think the idea of lakehouses is to have a single copy of data, one place for your analytics to go and run self-service analytics, right? So they also want the ability to go use the right tools, whatever they want for simplified development in one single place, and have the Apache Iceberg compliance so they can do that. So unified data platform for your self-service analytics, that's what lakehouses provide you. Interactive analytics with the tooling that we will talk about in a second, and also real-time analytics, right? The key is most of the organizations, the end users, the consumers, business analysts, they just don't want to wait for 2 weeks to get their access to data. They want real-time access, and that is what lakehouses will do. And then the cost-effective and scalability, because now you're storing data in S3-based data lakes, I think they're definitely cost-effective and they are scalable in terms of self-service analytics. So let's talk about the third building block here. This is self-service analytics for business intelligence has always been there, and nothing special about, but generative business intelligence really brings that self-service nature into our self-service manner with the analytics, right? The key is, you need a natural language interface, because not everybody is a BI expert, right? You want the ability for somebody to go simply provide natural language and create dashboards. So that's the self-service nature of this analytics, right? An automated insight generation like data storage, we will talk about it. Dynamic visualization, these are the generative business intelligence. So I'm sure you're all aware of this service called QuickSight. QuickSight has been doing business intelligence for a long time, right? So what we have done is, this is unified BI for all your end users. It provides you access to the data lakes and your lakehouses. But what we are going to talk about is QuickSight Q. QuickSight Q provides you the capabilities of, it basically takes that, it's a game changer in terms of self-service analytics when it comes to business intelligence. Why is that? There are 4 things that I want to talk about. One is it has AI-powered dashboarding, right? Authoring experience, where you can quickly author without creating, just using natural language, without being a BI expert. That's pretty important for self-service analytics. And then the storytelling, data storytelling, which I will talk about in a second, which is another key self-service enabler in QuickSight. And then on-demand answers. Imagine this, right? You give your massive dashboard to your CIO or CEO or CTO, whoever, the executives, and they look at this dashboard, it's great, but now they're finding a needle in a haystack, they have to go figure out all the dashboards. Now, what if you can simply ask questions of that dashboard in a manner where you can just, in natural language? And that is what this the AI answers on demand provides you. And that is a real self-service for all your organizations. And then the last one is the extended, so that you can embed these things into your applications. Now, let's go one by one here. So in terms of AI-powered authoring experience, this is BI always has been a self-service nature. But here what you can do is you can quickly, in natural language, create these visuals and add it to your analysis and add it to your dashboards. So you don't have to be a BI expert to do this, right? Simple natural language, and these are done behind the scenes. It's generative AI. It's basically running through Bedrock, and it's creating those visuals on your data sets. And then also you can create calculations. You can also refine the visuals, meaning you create a pie chart and then you say, oh, I want a stack bar or something like that. You can quickly create that, and that's what this feature does. And then the assisted storytelling. This is a pretty cool feature, and that's one of my favorites. You can create MBRs and PowerPoints for your executives where from your dashboard with a simple prompt, you can quickly create a prompt and then choose the dashboards, choose the visuals from your dashboard into a narrative format where you can create data stories. This is a pretty amazing feature where you can create PowerPoints or PDF formats and you can pass it on to your executives or to your customers. So this is storytelling. And also you can refine the content, you can add more, if you want to change some bullet points and things like that, it gives you that opportunity to do that. And then the last one is, this is an important feature, where AI answers to questions of data on demand. So you publish this dashboard, you give it to your 15,000 user base, right? Now what they can do is, they don't have access to the data, but they have access to the dashboard. We have provided ability for them to quickly, by using Amazon QuickSight Q, you can ask questions on that dashboard in natural language, and it creates the answers for you. Whether it could be another visual, or it could be a narrative, basically it's creating that. So let me run through a demo here. Let's take a business analyst who is basically targeted to harness the power of generative BI, right? To create the visuals, we need simple natural language. So what I'm going to do here is basically to create a visual, I just describe the visual, and then I will change it. So let's do that. And then the key thing is, this can be done by authors of the QuickSight dashboards, but also you can use the readers can also do that. There you go. So what I'm doing here is basically asking, okay, this is a simple natural language. I'm giving it a prompt, and I'd say, okay, monthly sales and profit. By simple natural language, it is creating a visual based on the data in my QuickSight. Now I can add that visual into my analysis, into that, and then I can create that. I can change, and I can also create forecasting. I can also do anomaly detection, other things, and I can add it into my dashboard. So this is pretty self-service, because now I don't need to be a BI expert to do this. Same thing, the sum of sales by city and product, it creates a map. I can move that region sales by segment, and I can also change the type of visuals by simple natural language, and I can create a Sankey diagram just by simply going into the visuals and doing that. Now, the idea here is to basically give the tools to your end users where they can quickly do that. Now I can create calculations. Here I'm creating month-of-month percent change in trials, where I'm creating those visuals, and I can quickly create the calculations by natural language. You can do it normally, but here we are basically creating that by natural language. I can use that field in another dashboard, and I can go and change that. This is a line chart, but I don't like the line chart. I want it to be a stack bar chart. I can quickly, in natural language, say, create me a stack bar chart, and then it will create a stack bar chart. Again, The idea of this is to be self-service for your end users, where they can quickly authors. You don't have to be a BI expert to do this, so it creates that. And then the last one, which I want to talk about, is the data story or storytelling, right? So once you have this, what you can do is you can create a story. You can. This is a simple prompt. You provide a data story. You can add your visuals into the data story, and then you can take those visuals and put that into your QuickSight data story. And then you can create a simple prompt. It's a natural language prompt of creating a narrative of your dashboard, because this is for end users who don't want to go through your dashboards, and this is where they can quickly get access to the insight. It creates a nice narrative in terms of for every dashboard, it creates a description of it, what it is trying to do. All of this is done through generative AI, and that's what QuickSight Q will do. And also you can change certain things. You can insert more charts. You can update these things, and then you can have more access to building these features. For example, here, it gives you the next steps. It makes you some recommendations in terms of the data that it has, and then it creates that. In terms of next steps, I want to put some bullet points. You can do that. You can format this data story, and it allows you to do that. Now, the idea of this is to have, again, that self-service nature of it. That way you can quickly create these and then create these visuals and expose to your end users. Now, one thing that I do want to talk about, I think these are the two features that Matt talked about this morning. So far, we have talked about structured data on how you can do self-service analytics in QuickSight. Now, with unstructured data, what we have enabled is now you can add unstructured data to the structured data in QuickSight. Meaning, if you are creating a visual and there is a complementary document or a contract document or a PDF or a bank statement, you can basically create, when you ask questions, you can append that, so that way you get the access to the data at the same time. So you're seeing a visual and also associated unstructured documents coming up when you ask questions. So this is a pretty cool feature. And then the other one is in the data stories, right? When we talked about data stories and we saw the demo on data stories, you can add unstructured data to the data stories, so it will complement these data stories by those documents, and it enables that self-service nature. So this is also, it's stories about your business, your MBRs, your other documentation, and it adds that relevant documents into that. Okay. Now, with the generative BI, even though QuickSight is already self-service, but generative BI makes it more and more enabler of your self-service analytics, right? One is it provides you natural language queries, ability to quickly ask those questions, dynamic visualizations, right? So I'm asking in natural language, I'm asking it to create visualizations which are dynamic. It can create that. Narrative explanations like data stories, which is another powerful feature. And then also we saw some forecasting and anomaly detection, which is predictive analytics. All of these tools available to your end users or business analysts who are basically using QuickSight Q, and that is where the self-service comes into picture. With that, let me hand over the mic to my friend Utkarsh Mittal, who's going to talk about data discovery.
So all the capabilities that Shrikant talked about can truly enable self-service analytics if you have access to the right data at the right time, right? In today's world, while data is everywhere, it's also spread across hundreds and even thousands of data silos within an organization. So a core challenge that data users face today is that how to find the right data at the right time for your analytics use cases. Now, even if you're able to find the right data, how do you make sure that you understand that data with the right business context and that you can build trust in that data? How can you get access to that data in a self-service fashion without having to go to your data admins, and spending days and weeks trying to get access to the data? And finally, once you have access to the data, how can you consume that data in the tool of your choice? So let's understand how Amazon DataZone enables self-service analytics by simplifying data discovery and data access management. So in any organization, on one side you have data producers. These are people like data scientists and data engineers who produce new data. And on the other side, you have data consumers. These are people like business analysts, data analysts, or business users who are looking to consume the data. Amazon DataZone bridges the gap between data producers and data consumers. On one side, it enables data producers to share the data that they're producing with users across the organization. And on the other side, it enables data consumers to find that data, understand it with business context, get access to it in self-service fashion, and then consume it in the tool of their choice. One of the key capabilities of Amazon DataZone is a business data catalog. Now, it's an enterprise-wide business data catalog where you can bring together all of your data, whether it's in AWS or in third-party sources. DataZone provides self-service capabilities that allow data producers to not only onboard this data to the business data catalog, but also enrich it with business context. So, for example, it provides a generative AI capability which allows you to automatically generate business metadata, for example, business descriptions and business labels of your tables and columns, and which can be a very powerful capability for a data producer because they don't have to manually add all of that information in the catalog, which can be a very time-taking job. They can also add data quality, data lineage on top of their data, which basically enables other users across the organization to build trust in their data. Then on the data consumer side, DataZone exposes this catalog to data consumers through a powerful catalog search, which enables data consumers to find the data in the catalog using business terms. It also provides a subscription workflow which enables data consumers to request access to the data in a self-service fashion. And finally, once the access is approved, DataZone also automatically grants access to the data consumers by automatically managing permissions and underlying systems. And once they get access, data consumers have access to self-service tools which they can use and leverage to consume the data that they have got access in the tool of their choice. So with that, let's take a look at a short demo and understand how DataZone enables self-service analytics. So here, I'm logging in to the DataZone portal, which is where you experience all of the capabilities that I've talked about. The first thing that we'll do is select a project. Project is how you work with data in DataZone. On the right-hand side, you can see that there are certain tools available in this project. So for example, at the top, you see there is Amazon SageMaker. Oh, it seems like there is a technical issue. The demo is not working. Really sorry for the inconvenience, but I think what I wanted to show from this demo was how DataZone enables you to find the data in the catalog, and then then data consumers can easily find the data, understand it with business context, request access to the data, and once the access is approved, they can start consuming that data in the tool of their choice. So that's exactly what Amazon DataZone enables for you. With that, I'm going to hand over the mic to my friend Raghav.
Good afternoon, everyone. My name is Raghav Sodabattina. I'm a principal solutions architect at AWS. I've been with AWS around 5 years. I help customers in building self-service analytics on AWS. Let me ask you one question. How many of you know you can solve complex business problems with self-service analytics? Just raise your hands. I see a couple of hands. Thank you. How many of you know how to solve those complex problems with self-service analytics? Anybody here? I see nothing. Good. Thank you. So I'll start with how to build self-service analytics solutions by using Redshift ML to solve complex problems. Also, I'm going to talk about various tools in order to enable self-service analytics. I will show you a few reference architectures and some tools to enable self-service analytics. At the end, I'll conclude with a few resources and how to get started your self-service analytic journey on AWS. Let us start with Redshift ML. With Redshift ML, you can simply create an ML model by using simple SQL. You can choose the ML algorithm based on your use case. Also, with the Redshift ML, it can pre-process your data, and then you can build the model, and then you can tune the model, and then you can deploy the model also. Also, you are going to pay only for training. All the inference comes with your Redshift cluster. So now we know what you can do with Redshift ML. Let us talk about how to do it. Amazon Redshift is a cloud data warehouse, typically used for storing a historical data with aggregations. You can bring data from a wide variety of data sources into Amazon Redshift. Once data is in Amazon Redshift, You can do business intelligence. You can run SQL analytics in order to derive the insights from your data. It also comes with a Redshift ML feature. That is where I'm going to double click on it. If you want to learn about Redshift innovation, there is a session called ANT349. It is happening right at this time, 1:30 p.m. Maybe you can watch the session in YouTube. Let's talk about what you can do with Redshift ML. You can use like a supervised training for advanced analytic use cases ranging from forecasting, personalization, or a customer churn. These are some of the use cases where you can use the data in a data warehouse. Now let us look at this slide, right? ML workflows can be complex and iterative. If you look at the slide, you need to start with data preparation, and then you need to choose the algorithm for your model, and then you need to build it, you need to train it. Once you build the model, you are going to evaluate model metrics to see whether that model is giving output as you want based on your business outcome. And then you need to deploy and manage. In general, you may rely on ML engineers or a data scientist to train the model for you. So now let us talk about how Redshift ML work. You can create an ML model as a data analyst or a database engineer by using simple SQL query, by using the data stored in an Amazon Redshift data warehouse. For example, to create a model, you can, let's say you want to predict a customer churn. You can query columns in one or more tables in the Redshift data warehouse. Like for example, customer profile table could be your input for the model training. And then you can have a target column like whether customer churn is active or not. Now let us take a simple use case. You want to build a customer prediction model by using a historical data stored in a customer profile data in a Amazon Redshift. And you want to ingest a data from business applications. Generally, you store business application data in a relational database like RDS or maybe Amazon Aurora with PostgreSQL Server, or any commercial databases like SQL Server or Oracle. And then you want to bring this customer profile data into your data warehouse so that you can aggregate those historical data. And then you want to create a model that is ready for use. Also, based on the model output, you want to create some visualization to see where customer churn is happening so that you can take some action then and there. So let's look at the architecture, how it looks like. If you look at, right, there could be a business application. As I said, business application generally stored in a relational database like Amazon Aurora database. And then you can bring the data without writing any ETL data processing pipeline. As Srikanth mentioned, you just need to enable Zero-ETL configuration between the Amazon Aurora and Amazon Redshift with a few clicks. Then you see the data in Amazon Redshift ML. And once model is trained, you can use this data output as a dashboard by using Amazon QuickSight, or you can create a basically data API so that other business application can share it. Let's quickly look at a demo here so that you can see. If you want to learn more about it, there is a Redshift ML workshop where you can do it yourself. If you look at here, I'm using a customer profile data stored in a table called customer activity table. And here I'm describing target as a column. I'm using that as a function. The function is going to be ML model here that is being created once model is deployed. Behind the scene, what is happening, Amazon Redshift ML is using Amazon SageMaker autopilot to run complex experiment on this customer activity data, and then it come up with the best model for the customer churn. If you look at here, you can see the result, and it is showing whether model is trained or it is ready. That is where we are just writing a SQL query to see the model. Once model is created, if you see this right now, it is training. I'm going to run another query and see now model is ready, and also you can see what algorithm I'm using, XP Boost. And then once model is created and deployed, this function is ready to be called as a SQL query to see the outcome from the model. Now here, I'm running this model by calling that function, give me the customer churn from the customer activity table. And it is going to call this function. The function is nothing but a ML model, and it is going to tell me, okay, this is the state where true or false. Now I can take this output, ML output, and then I'm going to create a QuickSight dashboard here and see how quickly you can create this output as a visualization, and then you can see where this customer churn is happening. That way you can take some action and then see how you can best retain your customers. If you see this good visualization where you can look at the state. If you look at this screen here, I think there is a Indiana state where you see a lot of customer churn is happening, so that your marketing team can look at it, what is happening there, so that you can take some actions there. So to summarize, you can solve complex business problems quickly and easily with Amazon Redshift ML. And you can build ML models with SQL, and you can choose the best ML algorithm based on your use case, and then you can try and tune and deploy your ML models. You just need to pay for model training. Model production is included with your Redshift cluster. Now, let us dive into next building block. Data engineering, SQL analytics, machine learning, and generative AI app development, some of the day-to-day functions for data users perform on a regular basis. And you need to empower data users to do this function independently. That is where you need to provide like a user-friendly or maybe low-code, no-code tools. For example, you can use EMR Studio or a Glue Studio for data processing, and Redshift Query Editor for SQL analytics, SageMaker Studio for machine learning, and Bedrock Studio for GenAI application development. Generally, organizations comes with like a teams or a project. You can bring the people to these tools by using your identity provider, right? It could be Archer or Auth0, where you can onboard the users into these tools. Also, all these tools comes with Git integration so that multiple data users can collaborate each other for a given use case. And this is all responsible self-service because you are enabling the compute as well as the tools so that they can perform the work. And this is a way like you are getting access to all of these tools quickly and easily. Let us dive into one at a time. So I'm going to talk about what are the tools for data processing, SQL analytics, machine learning, and GenAI app development. Amazon EMR make it easy for doing a data for big data processing frameworks like a Spark, Hive, Presto, HBase, Blink. And EMR can run directly the data stored in Amazon S3 data lake. And AWS Glue is a data integration service. AWS Glue comes with Apache Spark, Python, and Scala to support your data processing needs. And also, AWS Glue comes with ETL tool for all kind of users. For example, for business analysis, you have a visual editor kind of a tool where you can just drag and drop in order to build complex data processing jobs. And if some of the data engineers, they want like a coding kind of experience, it comes with Jupyter notebooks as well. So let us talk about how you can do the self-service analytics with EMR Studio. You can onboard your data users with EMR Studio with AWS SSO, or you can build a SAML federation with your identity provider like Archer or Auth0. EMR Studio comes with a fully managed Jupyter notebook, and also it integrated with Git repositories for easy collaboration. So you can also do the real-time co-authoring on notebooks as well. And with EMR Studio, you can basically browse, create, and delete EMR clusters based on your use case. Now let us dive into Glue Studio. Glue Studio provides a serverless infrastructure with Apache Spark, Python, and Scala. You can do batch data processing, micro-batch processing, as well as stream processing. You can also transform the data with tools. Visual ETL editor for data engineers who prefer for low-code, no-code development experience. Notebooks for data engineers who want a code-based experience. You can also use like IDEs like Apache Spark or Scala. And also it comes with a lot of transformations like where you can join the multiple columns. You can also do the missing values. Let's talk about nest tool. If you put everything together, with the IDE level, you can use either Glue Studio or EMR Studio. With orchestration workflow, you can use either AWS Glue workflows or AWS step functions or Amazon MWA. And the runtime could be Glue or Amazon EMR. If you are familiar with Apache Spark, we'll recommend you go to the AWS Glue. But if you want to deal with other big data frameworks like Hype, other frameworks, along with Apache Spark, then you can choose Amazon EMR. Let's talk about self-service SQL analytics with Redshift. You can use Redshift query editor for SQL analytics powered by generative AI. For example, business analysts, they can use natural language just to create a SQL queries. They don't need to know the SQL syntax and all. And then take that query and then run the queries on fly in a query editor so that they can derive the insight right away. Now let us look at how it works. You can write the SQL queries by asking questions in a natural language. That way it will provide you the coding recommendation. That way you can get the results pretty quickly. Machine learning with SageMaker AI. As you heard, we have a next generation of SageMaker. The existing SageMaker, we are calling it as a SageMaker AI. Don't confuse with what is SageMaker AI. Okay, SageMaker comes with a lot of features and capabilities. We typically talk about falling into 4 categories. Data preparation, the model build phase, training and tuning, and deployment and management. With these 4 categories, you can build end-to-end machine learning pipelines on AWS. With SageMaker Studio, you can build ML models end-to-end. Let us double-click on SageMaker Studio. SageMaker Studio comes with a Jupyter Lab, where you can launch them fully managed Jupyter Lab in seconds for interactive development. And also, there is a low-code, no-code data preparation with Data Wrangler, where you can quickly build data preparation for our ML models. You can also choose models, or you can choose the pre-existing build. There are about 300 publicly available models available within the SageMaker Jumpstart, which includes some of the foundation models as well. And SageMaker also supports a major frameworks like a TensorFlow, PyTorch, Apache Next, and Hugging Face as well. You can monitor all your ML models within the SageMaker Studio as well. You can also deploy the endpoints by using Amazon SageMaker Studio. Let's quickly talk about AWS Generative AI stack. The bottom layer where you can see we provide required ML hardware. If you want to build your own foundation model, you can use this hardware to build the model. Today you heard about Keynote, where Anthropic is using AWS hardware to build this foundation model. And Amazon Bedrock comes with many foundation model where you can build generative AI applications by using your data. As you know, when it comes to generative AI, you can do any design pattern, like be it a prompt engineering or a RAG or fine tuning. All this, it comes with a lot of models. And then Amazon Q for Business, you can automate a lot of things where Amazon Q can connect with many of your enterprise data sources, be it a Salesforce, or it can even connect to the SharePoint, and it also provide insights about the AWS services as well. With Amazon Q Developer, you can write a code. So let's talk about what tools today. Today we have a Bedrock Studio where you can build a generative AI application using various features. For example, Amazon Bedrock comes with a model evaluation where you can quickly look at the models, what model is suitable for your use case. And then Amazon Bedrock Knowledge Base, where it can automate RAG kind of a design pattern so that you can connect with your domain-centric data to build the generative application. And also Amazon Bedrock Agents, where you can automate some of the complex tasks. For example, if you are building a claim processing pipeline, you can ask Amazon Bedrock Agent to automate these things. And finally, Amazon Bedrock Guardrails, where you can build responsible AI policies. Like you want to do the word filter, you want to deny some topics. Also, you can do you can radiate peer-related data. So now, let us talk about Amazon SageMaker Unified Studio. This is what you heard today keynote, and Srikanth already talked about lakehouse. And then data and AI, where it comes with the business catalog. That is where you can do the data discovery and you can find it. So Amazon SageMaker is for unified development experience. Again, it is in a public preview. You can do the data preparation, model building, and generative AI application development by unifying tools like notebooks, query editors, and across various AWS data services. And it integrates seamlessly with EMR, Glue, Athena, MWA for data processing, Redshift for SQL analytics, SageMaker AI for machine learning, and Bedrock IDE for Gen AI development. And you see some of the things which we plan to support: streaming, searching, search use cases, BI services in sometime in 2015. Again, the way EMR Studio, Glue Studio, you can onboard your data users by using AWS SSO, or build the SAML federation with your identity provider. And your data users can use existing project, or you can create a new project based on your business use case. With SageMaker Unified Studio project, you can share basically compute data and code with other data users to solve like a complex problems based on their job function or a user role. So that you can solve that complex problem easily. If you look at, this is the UI of Amazon SageMaker Unified Studio. Give me a minute. If you look at here, there is a various tools here. You have a Jupyter Lab under ID and applications. And you have like a query editor, visual ETL tools, and under machine learning generative AI, you have all this. When you come here, you have 3 tabs. You can see like discover, build, and govern. Discover, where you can discover the data, and then under build, you can use various tools to empower self-service analytics. Under govern, I mean any data stewards, they can create the policies so that they can provide the access to tool based on their user role. So let me talk about a little bit more about. We talked about data processing. Data processing within Amazon SageMaker Unified Studio. You can use notebooks, where you can create a notebook, and you can also get the suggestion within the notebook powered by Amazon Q. And then for SQL analytics, there is a query editor within the Unified Studio, where the way you are doing like doing a natural language, you can use that natural language to create a SQL analytics as well. For machine learning, SageMaker AI comes with various tools that is also there in Unified Studio. For Bedrock, we have a Bedrock IDE, which is in preview now. And it comes with all the Bedrock Studio features where we have today. You can start using this Bedrock IDE in preview for some time, and then later on you can start using. And again, all these tools are powered by Amazon Q Developer, where you can get the suggestion how to use the tool or how to collaborate and all. So let's talk about, let's take a simple use case, very complex use case, where you wanted to basically use a lot of users within the organization to solve a complex problem. And you want to build a personalized recommendations model to improve the customer experience. And then you wanted to provide like a unified development environment, that way multiple personas can interact each other. The important thing is that model is ready to use. Let's talk about, first we have to do is create a SageMaker Unified Studio project. And then for, let's say, your business analysis is coming, and they are going to do the data exploration, whereas they can use the SQL editor to find out how the data is there. And then data engineer comes and look at the SQL editor, whatever the business analysis did, and then look at maybe the data engineer can use the notebooks or a visual ETL to do some data processing for model. And then model build, then machine learning engineer or a data scientist come there, and they can use the SageMaker AI or notebooks experiment to build an ML model. And then ML apps engineer, they can look at the model and evaluate this model against the model metrics, and then choose the model which is good for their business use case. And at the end, application developer can come and look at that model and then take the inference endpoint and integrate with the business use case. If you look at it, you are empowering various business users to solve a complex problem. And you're also doing like a data literacy and adoption by sharing notebooks, by sharing the code across various personas to solve a complex problem. And also, you're getting a faster insight, and you're making a decision because all these people are collaborating each other within a SageMaker Unified Studio project. And then by doing this, you are improving operational efficiency because you don't need to deal with sharing the code and doing the GitHub. They all can come to the Unified Studio project and then look at what business analysis did, and then data engineer take it from there and do the further data processing, and then data scientists come there and then look at whether the data is ready for model build. At the end, right, it is kind of a modular approach where you have one business process. Each business process you can tool. For any data-related job, Unified Studio comes with the tool so that you can solve this complex problem pretty quickly. To summarize, focus on creating a business value by simplifying unified development with specialized tools and editors to empower your users. That way, you don't need to worry about infrastructure management and tools and all. Just do the onboarding. All these tools comes with Amazon SageMaker Unified Studio. Now, there are a few of the resources here. For example, I talked about Glue Studio. There is a good blog you can learn about how to use Glue Studio for self-service analytics. And there is EMR Studio, I talked about it. There is a good blog about how you can use that. And then I wanted to, if you want to learn more about Amazon SageMaker, these are the sessions. Take the picture of this. You can attend any of these sessions. We just talked very high level about self-service analytics aspect of Amazon SageMaker, but there are separate breakout sessions where you want to deep dive into Amazon SageMaker Lakehouse, Amazon SageMaker Business Catalog, or you want to learn more about Amazon SageMaker Unified Studio. With this, thank you all for your time. Please help us completing survey in a mobile app. Again, we will be here at the podium for some time. If you have any questions, feel free to come forward. We are happy to answer any of your questions.